later. So our first question says round to the nearest whole number. So that means I want to keep everything on the left side of the decimal point. So the only thing I have to ask myself in these problems is, should the last number change? I answer that question by looking at the neighbor, so looking at the next number. If the neighbor is bigger than 5, I'll change the last number and only the last number. In this case, it is not. So my answer to this problem is 1,296. Our next problem says round to 3 significant figures. So I'm going to go ahead and highlight the first 3 numbers. So I know my answer will be 77.2 or 77.3. So I look at the neighbor, and in this case, the neighbor 6 is larger than 5. And that means I'm going to change the last number, but only the last number, giving me 77.3. Alright, next one says to round to 3 significant figures. So in this problem, we see that these two on the left are called leading zeros. Leading zeros, they still need to be accounted for, but they're not significant. So my first significant number is this 7. So the 7, 2, 7 are significant. I look at the neighbor, and once again, the neighbor is larger than 5. That means I'm going to change the last number and only the last number. So my answer will be 0.0728. The only time I would change anything besides the very last number is if that last number was a 9. Alright, next we're going to work on some conversions. So we're going to start by converting 77 centimeters into meters. The way I set up my conversions is I call them train tracks. So starting in the upper left-hand corner, we're going to start with what was given, which is 77 centimeters. So this right here is our given. Next we're going to use conversion factors. So I know I need to change 77 centimeters into meters, and I know that the relationship is that 1 meter equals 100 centimeters. Since centimeters is on the top right now, I need to put centimeters on the bottom to cancel that out, and meters on the top. Again, I said it was 100 centimeters was equal to 1 meter, and so I have it set up. Again, I knew centimeters should be on the bottom so that centimeters could cross out. So now I will multiply across the top, divide across the bottom. I don't need to type in the 1, so I'm just doing 77 divided by 100, which gives me 0.77 meters. Let's take a look at our next one. So next we're converting 18 meters into feet. So to set this up, I have my given of 18 meters. I know that the relationship between meters and feet is that 1 meter equals 3.28 feet. Since I have meters on the top already, I need meters on the bottom to cancel it, and feet on the top. My equation says that 1 meter equals 3.28 feet. So the 3.28 will go with the feet on the top. Again, I put meters on the top and bottom to cancel it out. So 18 now times 3.28 gives me 59.04. I could keep that whole thing or just the first 3 significant figures. I'm going to go with 59.0 feet. Alright, next we're converting a speed into another speed. So in this case, my given is 66 centimeters, and I'm never going to write this slash right here when I'm doing a conversion. Instead of the slash, I'm just going to use the bottom half of the train tracks. So again, this is my given here, 66 centimeters per second, but that seconds is going to go on the bottom. Alright, I know in this problem, I need to change centimeters into meters, and I know the relationship is 100 centimeters equals 1 meter. Since centimeters was on the top, I need to put centimeters on the bottom so that they'll cancel out. I'm actually done with this problem because I have my goal. I wanted to get to meters per second. That seconds did not need to change. So I'm actually done. This is just a one-step conversion. We'll get into two-step conversions later. So 66 divided by 100 just gives me 0.66. and now my answer is in meters per second. The next problem asks me to convert 15 miles per hour into feet per second. The first thing I want to do in this problem is whenever I see this unit miles per hour, I'm going to cross it out and change that to mi/h, which is a better way to write it. So I'm going to set up my train tracks again, and my given is now 15 mi over h. I know I need to change, in this problem, miles into feet. So let's go ahead and do miles into feet. So I know that there are 5,280 feet in a mile. So those will go on the top and bottom of the next step of my train tracks. Since I had miles on the top, I'm going to put 1 mile on the bottom. And that 1 mile is equal to 5,280 feet. Canceling out miles. Now I'm left with feet over hours, but what I want is feet over seconds. So the next thing I need to do is change hours into seconds. So I'm going to go ahead, I use this a lot, so I'm going to use the conversion factor that 1 hour equals 3,600 seconds. That's just 60 times 60 to make this a little bit shorter. So since I have hours on the bottom right now, I need hours on the top. So I'm going to put hours on the top and seconds on the bottom. So 1 hour on the top, 3,600 seconds on the bottom. I can now cross out hours since it's now on the top and bottom. This one was a little bit tricky because hours started on the bottom, so now I need to put it on the top. Into my calculator, I'm going to plug 15 times 5,280 divided by 3,600, since the 5,280 was on the top and the 3,600 was on the bottom. And that actually gives me a speed of exactly 22 feet per second. Coming down to our last problem, I want to convert 21 meters per second into miles per hour. Again, I'm going to think of miles per hour as mi over h. Setting up my train tracks, I start with 21 meters per second as my given. I need to change meters into miles. I'm going to use the conversion factor that 1,609 meters equals 1 mile. Meters was on the top, so I need that 1,609 meters on the bottom and miles on the top. I can go ahead and cross out meters then, and I have successfully changed meters into miles, but I still need to change seconds into hours. So next, I'm going to write down that 3,600 seconds equals 1 hour. Well, since seconds was already on the bottom, I need that 3,600 seconds to be on the top and the hours to be on the bottom. That way I can cross out seconds and be left with exactly what I want, which is miles on the top and hours on the bottom. So I can do 21 times 3,600 divided by 1,609. Just make sure you multiply across the top, divide across the bottom, but it doesn't matter the order. And I get 46.98, which rounds to 47.0 miles per hour, which can be written mi over h or mph. And that is it. Be careful on this problem. There is in this section, sometimes there's a section that asks you to convert a feet into a distance into a speed or something like that. In that case, you'd hit the cannot be determined button.
Alright, in this video we're going to learn how to extrapolate. So this is really important, especially in the inquiry activities. So in this problem we're given values for x and values for y, and we're supposed to predict this value when x is 80. So if you click on the Desmos graphing calculator, you'll get a screen that looks like this. Click on the plus in the upper left hand corner and click on table and go ahead and enter your data. When you enter your data, you can leave this last one blank that you're supposed to predict. Now your points probably won't show show up on the screen. But Desmos has this really nice feature where if you click on the zoom fit, you'll be able to see what your points look like. So if I'm looking at these, it looks like it's probably not a linear relationship. So since it doesn't appear to be a linear relationship, I'm going to create a best fit line. So how I do that is I'm going to type in y equals, and I'm going to type in my first value for y, 82.7, open parentheses, then x divided by that corresponding value for x, so in my case 20. Close the parentheses, and then we're going to put in a exponent that I'm going to call p, and then click on add slider. Alright, so this guarantees that our line or our curve will go through our first point, but since it wasn't a linear relationship, we need to adjust p to make it fit. In my case, I got p equals 2. So it's a quadratic. And now I can guess a value for 80. I might have to zoom out a little bit. So for 80, it looks like it is way up here. Let's guess 1,000. Now 1,000 was too low, so I'm going to keep increasing my answer. 1,100 was too low, 1,200 was too low. 1,300 looks about right, but I'm going to go up a little bit higher. Positive physics would probably accept this. We set the tolerance to 5% for this one. And that looks about right. So 1325, I'll enter my answer over here. And the correct answer was actually 1328, but we were really close on this. So that is how you extrapolate.